Hello, I welcome you all to this another interesting screencast. We're going to be solving this engineering mechanics problem, and it reads determine the maximum and the minimum values of weight W, which may be applied without causing the 50 pounds block to slip. The coefficient of static friction between the block and the plane is mu s equal to zero point 0.2, and between the rope and the drum D is equal to mu prime s equal to zero point 0.3. This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. So we have been asked to determine the maximum and minimum values of the weight W, which may be applied without causing the 50 pounds block to slip. Let's call this block as block A, and we call this other block there as block B. Okay. And we want to use this particular equation T2 is equal to T1 E, which is a constant, a base of a natural log, to the power mu, okay, times beta, which is the angle between the rope and the contacting surface, and it is in radians. So T2 in this case is always larger than T1. So we'll need to choose which one is T2 and which one is T2. So T1 and T2. And since we have been asked to determine the maximum and the minimum values of block B or weight W, so I'll have two cases. So let's dive directly into the cases so that we begin to work on the problem. Right. So we have case 1. Okay. And in this particular case, we are going to use block A as our reference. Okay. And by reference, I mean when I say downward motion, upward motion, I'm referring to block A. And then I'll explain. So case 1, let's assume in this case that we have what is called a downward impending motion. Okay, so we are assuming that block A is tending to pull block B. Okay, we are assuming that block A tends to pull block B. Okay, so there is this tendency for block A. I write here also block A. So there is this tendency for block A to move downwards. It is pulling block B, or it has a tendency to pull on block B. If this is the case, then we expect some friction in the opposite direction. So we are assuming that it tends to move in this direction, downwards. Therefore, if that is the case, then we are going to assume our friction is like this. Okay, and then we have our normal force in that manner. Okay, and then because we have assumed that this block A tends to or to experience impending motion in a downward direction, and it tends to pull on block B, therefore our block B, the tension cable connected to block A will have a tension that we are calling tension 2. Okay, and that is how we are choosing our tension. Which one is tension 2, which one is tension 1? Because block A tends to pull on block B, therefore the tension connected to block A is going to be tension 2. Block A tends to pull on block B, therefore the cable connected to block A is tension 2. Okay, hope that is clear. So having said that, then we know that block A has some weight W, okay, which is 50 pounds. Okay, let me just indicate it as W for now. All right. So this W is going to have components. It will have components in our coordinate system. So this is our coordinate system. This is our X. This is our Y positive. Okay. So we'll have a component in this direction. We'll have a component in that direction. Okay. It's a component of W. This angle here is theta, and our theta is equal to 45 degrees. So this one here is going to be equal to W cos theta. Then we'll have another one in this direction like this, and this one will be W sine theta. Okay, is that fine? Great. So we are done with this particular case. So what we are going to do now is to quickly apply the equations of equilibrium. For this case number 1, where we are assuming block A tends to pull on block B, therefore the cable connected to block A is our T2. Okay, and we say T2 is greater than T1. So in this particular case, we are trying to find T1, right? Because we have assumed our T2 is this tension cable connected to block A. Then later on, we'll move on to case number 2. So let's continue with case number 1. So quickly, we are going to apply the summation of forces in the y direction like so. Okay, there we go. So what do we have? In the y, we have n, okay, minus w cos theta equal to 0. Then summation of forces in the x direction, what do we have? We have T2 minus w sine theta, then plus f equal to 0. Mind you, I didn't make mention. We have how many unknowns? We have T2, we have f and n. We have 3 unknowns, and we only have 2 equations of equilibrium. Okay, and since we are talking of minimums and maximums, we are going to invoke the friction equation so that we have F equal to mu S times N, which is equal to 0.2 N, because we are on the boundary. Alright, so we have all the equations necessary. So what we can do now is we can begin to do the calculations. Right. So let's now solve these equations. Let me try and move these equations maybe to somewhere here. Right. Okay. So using this equation, this one here, using this equation, we use red. Using this equation here, we know that our W is equal to 50 pounds, right? And our theta is equal to 45 degrees. Therefore, N will be equal to, the normal force will be equal to, when we punch it in our calculator, we'll find it as 35.3553. Okay. What units here? Pounds, right? So since we know that F is equal to 0.2 times N, this will give us a value of 7.0711 pounds. Okay, then using this equation here, we're able to find what T2 is, since we have F and we have N and we have W and theta. So here we just replace our F and theta and W. Therefore, we are going to calculate what our T2 is. So our T2 is going to be equal to, this is for case 1. T2 therefore will be equal to 28.2842 pounds. Alright, so we are done with the case 1. We are going to calculate them together after we found both cases. Okay, so let's go to case 2. Let's just find the tensions and then we'll calculate them together. Alright, or should we go ahead? Maybe we can go ahead. Let's just calculate it. So using our equation, T2 is equal to T1 E, which is the base in natural log, times to the power mu times beta, and beta is the angle over which the rope is in contact with this cylindrical drum. So we know that if this is our center here, let's find what beta is. We're trying to find beta. Okay, this part here is 90, and the other point where the cable is in contact with the drum or the target points, so it is that point there. Okay, so we know that this is 45, therefore this angle also will be 45. So 45 plus 90 is let me use the other color for this one. So we know that this one here is 45, therefore this also here of course is 45. So 90 plus 45 is 135. So our beta is equal to 135 degrees, and converting beta into radians, beta will be equal to, okay, we know how to do the conversion. Can I do it? Well, we know that 2 pi is equal to 360 degrees, and when the 135 we want beta, right? And therefore our beta will be equal to, if we cross multiply it, then this becomes 2 pi times 135 divided by 360. Therefore, our beta is going to be equal to 3/4 of pi, which is 0.75 pi, like so. Great. So let me just move this a little bit so that I have some space. Let me create a little bit of this boundary here. So if we are there for now to do the calculations, we'll say that our T2, we already know what it is. Our T2 is, we are still on case 1, 28.2842 equal to T1 e to the power mu. What is our mu? Our mu is equal to, we've been told mu prime s, which is equal to 0.3. Okay, so this one is 0.3. Let me rub this part. 0.3 times 0.75 pi. Okay, let me move this down. I move it like so. Okay. Alright, so if we are to make T1 therefore subject to the formula, we'll find that our T1 therefore will be equal to 13.8 9495 pounds. All right. So we found the first case. Let's go to the second case. All right, let's do the same like before, but the assumption is different. So case 2, the motion here we have what we are calling the upward motion. Okay, so we are saying upward impending motion. Okay, upward impending motion for the same block A. So what are we saying here? So we are saying in this particular case, we are assuming that block B is the one that tends to pull block A. I repeat again. Here we are saying block B is the one that tends to pull block A. Block B tends to pull block A. Therefore, block A has a tendency to move upwards. So if block A is going to experience what we are calling upward impending motion, then we expect some friction, right? If it tends to move like this, okay, therefore friction for this block A will be in this direction like this, right? This is F, and then we have our normal force like so. Okay, and then the tension connected to block A will be what? It will be T1. Okay, all right. Why? Because the block B is the one that tends to pull block A. Therefore, the tension on block A becomes what? T1. It's very important. So we have the weight. We have the weight on block A, just like before, W. Okay. And later on, we are going to have components in that manner. This angle being theta, and we know that our theta is equal to 45 degrees. So this becomes a W cos theta. Then we'll have another component in this direction, in the horizontal inclined direction. This one is W sine theta. Okay, I think we are done. So what we just need to do now is to apply the equations of equilibrium quickly. So we have summation of forces in the y equal to 0, going up being our reference, and then this is our coordinate. Okay, it's inclined. Okay, this is x positive, this is y positive. Okay, so there we go. What do we have? So in the y direction, we have minus w cos theta plus n equal to 0. Summation of forces in the x direction. Okay, what do we have? In the x direction, we have T1, alright, minus W sine theta minus F equal to 0. Because we have 3 unknowns and only 2 equations of equilibrium, and we are looking for a maximum or minimum, so we are going to invoke the friction equation at the boundary. And that is F equal to mu s times n, which is equal to 0.2 n. Okay, so let's solve these equations of equilibrium. So we know that n w is already known. So we are using this equation here. So W is known. W is equal to 50 pounds. Theta is equal to 45 degrees. Therefore, N will be equal to, like in the other case, N won't change. It will be the same value, which is 35.3553 pounds. Okay, and see if we can find N, therefore we can find F, the friction, which is just 0.2 N, and therefore this one is going to be equal to, also it won't change, it will just be 7.0711 pounds. Alright, so now we are using this equation here. See, in this equation we have W, we have theta, and we have F. Therefore, we are able to find what T1 is. Making T1 subject to the formula, we are going to find that our T1 will be equal to 42.64 pounds. Okay, so then using this equation where we have T2 equal to T1, e to the power mu times beta, where mu is equal to 0.3. Okay, remember the mu, right? Mu is 0.3. It is given in our problem. Mu is equal to mu prime s, which is 0.3. And then we have beta, which we already calculated, is 135 degrees, but we need to convert it to radians, and we found is 3/4, which is 0.75, 3/4 of pi, 0.75 pi. Plugging all these values in this equation, this one, okay, plugging all those values there, then we are going to have T2 is equal to T1, and T1 is 42.4264 times e to the power 0.3 times 0.7 pi. Okay, let me just move this a little bit like so. Okay, so there we go. So we have everything in there, and if we are to calculate our T2 will be equal to 86.0242 pounds. Okay, so we have found that the minimum value of W is equal to this value that we just calculated. Where is it? We calculated it somewhere. This one here. Okay, this value of T1. Okay, so that is the minimum value of W, which is equal to, this value is equal to 13.95 pounds, and the maximum value of W, we are just from calculating it, is this one here, and it is equal to 86.02 pounds. I think this is about it. We found the minimum value and the maximum value of W, which after it has been applied won't cause the 50-pound block to slip. So when either the minimum or the maximum value of W is applied, we are saying it is not going to cause the 50 pounds block, which is block A, to slip. I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and sharing my video as well as my channel. Bye bye, and see you in my next screencast.